Good evening, everyone. I request Gurvinder sir to conduct the session.
Thank you, sir. So, hi, hello everyone. Yesterday we were discussing about limits. So today, continuing with the same question. So the existence of a limit we'll be discussing today. So what is meant by existence of a limit? When do we say that a limit, like we have limit x tends to a f of x, it exists when both its left hand limits and right hand limits exist and they are equal. Fine. So both LHN and RHL should exist and they should be equal. So this x tends to a minus and x tends to a plus. Both of these should be equal in value. So let us just have a look. So this was the question given to you in homework yesterday. Okay. So can you help me evaluate 1 minus? So limit x tends to 1 minus and limit x tends to 1 plus. So what will be the value over here? 1 minus. Which of these function will it go for? Will it go for 1 plus x square or will it go for 2 minus x?
2 minus x,
It
sir.
is 1 minus. So 2 minus x. Okay. Anyone else? It is 1 minus. Okay. So my x is 1 minus 1. This is 1. So is it going, is my limit approaching from left side or right side? Is my x to the left side of 1 or to the right side of 1?
Left side to
Left side of
left
the
side
1.
to
Left side of 1. Okay. So can you tell me, is it lesser than 1 or greater than 1?
lesser than one.
Lesser 1.
Certain months.
So so why should it approach like why should it be 1 plus sorry, why should it be 2 minus x?
One.
Vignesh, it should be 1 plus x square, right?
Yes, sir.
Because it is lesser than 1. It is lesser than 1. So yeah. So its value will be equal to 2, right?
Yes, sir.
Everyone? Its value will be equal to 2, right? And what about this thing? It is 1 plus, right? 1 plus. So it's to the right side of 1. So it will follow this thing because it is greater than 1, right? So it will follow 2 minus x. 2 minus x, right, everyone?
Yes, sir.
Okay. So what is 2 minus x? Value?
One.
One, sir.
One,
1.
sir.
Correct. So is the limit existing?
No, sir.
No. Limit does not exist. Okay, not an issue. Not an issue. So we'll just do one more similar question. So I have f of x being defined as cos x. Okay. And x plus k when x is less than 0. So it is telling me that limit x tends to 0, f of x is existing. So find the value of k. Okay. So obviously, if it is existing, so that means at 0 minus and 0 plus, it should be same. So can we first find at 0 minus? 0 minus.
Yes.
So can you tell me at 0 minus, which of these will it follow? Will it follow x plus k or cos x?
X plus
0
K.
minus.
X plus
Correct.
K,
It
sir.
will follow x plus k. X plus k. So its value, x value is tending to 0 minus. In this case, it is 0 plus. So what will be the value of this thing, x plus k? What will it be equal to?
Zero. Zero.
It will be equal to
K,
k,
sir.
right? It will be equal
Yes.
to k. 0 plus k. So it will be equal to k. What about 0 plus? It will go for cos x, right?
Yes, sir.
It will go because it is greater than 0. So what is cos of 0?
One,
1.
sir. One.
What? 1. Okay. So this was the RHL and this was the LHL. And my LHN and RHN have to be equal, right? In order for my limit to exist. So what is my value of k?
1, sir.
Okay, correct. My value of k is 1 if my limit is existing. So this is just a basic about algebra of limits you can see on the left side. So I'm just assuming that limit extends to a f of x is equal to L and limit x tends to a g of x is equal to m. Both are existing and these are their respective values L and m. Okay. So if I'm adding two functions f of x plus g of x and or I am subtracting them, the same way my values of limits can also get added or subtracted. If I'm multiplying two functions, the same way their limits can also be multiplied. If I'm dividing two functions, so just one small thing you need to keep in mind, when you're dividing, you can divide the limits, but just keep in mind that m is not equal to 0. So, Gayatri, can you tell me why m should not be equal to 0? Why the limit x tends to a g of x can't be equal to 0?
Because it could.
Because it? Vignesh, bolo.
So then it could be in undefined, sir.
It is not defined, right? Division by 0 is not defined. Correct. So that is why when we are dividing two functions, we just keep in mind that the denominator function should not be 0 at that point. Fine. Then we have multiplication with a constant. If we are multiplying a function with a constant k, so this limit also gets multiplied. If we are taking the modulus, so we can take the modulus on the limit also. If we have f of x raised to g of x, one function raised to another function, so we can just take the limits, individual limits, and raise it to the power. If we are taking f of g of x, f of g of x, so one function inside the other function, something like this. So same way, you can evaluate both of the limits. You can both evaluate g of x first and then apply it to apply it inside. So it will be equal to f of m because g of x is equal to m. So this way you can do it. Okay. So evaluation of limits, the first and really simple ones, direct substitution. So these all of these are direct substitutions, right? Uh, limit x tends to 1, 3x squared plus 4x plus 5. How do you do it? You just plug in the value x as 1. So 3 into 1 square plus 4 into 1 plus 5. So its value is equal to 12. Very easy, right? Same thing, limit r tends to 1, pi r square. So in pi into 1 square, pi, really simple. Then what about here? Limit x tends to 0, ax plus b by cx plus d. You just input the value x is equal to 0 and you get your answer b by d. Same thing here. Limit x tends to 2, x square minus 4 by x plus 3. So 2 square minus 4 by 2 plus 3, 0. Same thing over here. Limit x tends to 4, 4x plus 3 by x minus 2. So you can do this. Right? Everyone got it? Got it? Got this thing,
Yes.
right? We have done this yesterday also.
Yes, sir.
It is direct substitution. You are just inputting the values of x. So there is nothing there is nothing abnormal or there is nothing new in this. If you know a function, so you can just directly substitute the value of x and find its limit at any given point. But now comes the ambiguity. Now comes the ambiguous part. So I have a limit x tending to 2, x square minus 5x plus 6 divided by x square minus 4. What will happen if you plug in the value x is equal to 2? What will happen?
0 by 0.
What will happen?
Infinity.
So you can see it. Okay, correct. It is 0 by 0, right? 0 by
Yes.
0. Correct. Same thing, you do it over here. Limit x tends to 1, x cube minus 1 by x minus 1. What is this thing equal to?
0 by 0. 0 by 0.
0 by 0. What is 0 by 0 actually? What is 0 by 0? It is not defined, right?
Not defined. Yes, sir.
0 by 0 is not defined. Same thing, not defined. So similarly, we would have a list of many problems that could be found with this, like limit x tends to 0, sine x by x. Or let us take limit x tends to 0, tan x by x. What will it be equal to? What is sine x by x when x is tending to 0? What will it be? What is sine 0?
0.
Correct. Sine 0 is
0,
0.
sir.
So this thing will also come to 0 by 0. What is tan of 0?
0.
It is also coming out to be 0. Okay. So we have faced an issue, right? everyone feels that we have faced an issue. We are not able to evaluate the
Yes.
value of the limit, right, everyone?
Yes,
So what do we do now? What do we do? So we use factorization. Okay. So just looking at the first example, I have limit extends to 2. X square minus 5x plus 6. So see, for the ones who have attended the previous classes, they might be knowing this, I guess. Right, everyone?
Yes,
Because we
sir.
have done such questions in the immediately first class. Okay. So how do you factorize the numerator and the denominator? So numerator can be written as x minus 2 into x minus 3, right? And your
Yes.
denominator can be written as x minus 2 and x plus 4, right? A plus b into a minus, right? Everyone? Right?
Yes, sir.
yes, sir.
Okay. Okay. So can I cancel out x minus 2 and x minus 2
Yes.
from both numerator and denominator? Is it
Yes.
allowed? Is it allowed?
Yes.
Okay. So like, okay. So like for the one who is saying no. So why do you feel that you can't cancel out? Is it because both of these values are 0? Right? That is what you think.
Yes, sir.
Both of these values are equal to 0, so they can't be cancelled out from numerator and denominator. Yes, you are correct. Like your thinking is correct. You are thinking in the right direction. But one thing you are missing out. What is the basic concept of limit? What is the basic concept of limit? See, if I am talking that x is tending to 2, okay. So basically, I am trying to say that the value I am talking about is not equal to 2. It is a value that can be either on the left side or right side of 2, okay. So basically, if I'm telling you that x is tending to 2, so x is not equal to 2. So basically, x minus 2 is not 0. It is a very small value, or rather say very small finite value. So it can be something like 0.000000001, something like this, but it is not equal to 0. So what will happen if it is not exactly equal to 0? What will happen? If it is not exactly equal to 0, it is a finite value. It can be cut from both numerator and denominator, right?
Yes, sir.
Everyone got it? Yeah. That is the basic concept of limit. See, if I say x is equal to 2, x is equal to 2. So you can say it is exact 0 by exact 0. So it is not possible to cut it. But I am telling you that limit x is tending to 2, not equal to 2. Fine. So yes, you can cut it. So you will be left with limit x tends to 2, x minus 3 by x plus 2. What is this value equal to?
Minus
What is
1
this value
by
equal to?
4.
Everyone.
Minus 1 by 4.
Minus 1 by
Minus 1
4.
by 4. Correct. Minus 1 by 4. Absolutely correct. Correct. Okay. So this is how you approach it by factorization. Okay. So looking at the next question, x cube minus 1 by x minus 1. Okay. So I have limit x tends to 1. X cube minus 1 by x minus 1. Can you think how we can factorize this thing? X cube minus 1. How is it possible?
A cube minus
Correct.
x cube
A cube
minus
minus b cube, right? Yes, yes. X cube minus 1 cube. So it will be equal to a minus b into a square plus ab plus b square, right?
yes, sir.
Everyone? Okay, great. Whole divided by x minus 1. So can I apply the same logic again?
Yes, sir.
Can I cancel out x minus 1 and x minus 1? Everyone?
Yes, sir.
So it is equal to limit x tending to 1, x square plus x plus 1. What is this value equal to?
3, sir.
Sir, 3,
3,
sir.
correct. It is equal to 3. Okay, correct. So similarly, you will be able to do such questions. It is not something really complex. Okay, so let us just do one with the trigonometry case. Okay. This one is not exactly factorization. It is more of logic. So I have limit. Okay, so, okay, just a minute. Okay, not so. So I have limit x tending to pi by 4. Okay. I have 1 minus sine of 2x whole divided by 1 plus cos of 4x. I hope all of you remember the trigonometric identities, right? Everyone?
Yes, sir.
Yes, sir.
You have learned trigonometry, right? यार ये मत बोलना कि trigonometry नहीं पढ़ा. Trigonometry is completed, na everything. Class 11 trigonometry has been completed, right? By Kevin sir. Okay. So can you just think first of all, what is the issue with directly evaluating this thing? What is sine of 2x when x is close to pi by 4? What will happen?
Sine 90 degrees.
Sir.
What is sine 90?
1
What is sine
minus
90?
0.
0, sir.
1 minus 0. Ah,
1
1
minus 1.
minus 1, right? So 1 minus 1 is 0. Yes.
Yes, sir.
And the same thing in the denominator, your cos of pi is minus 1. So 1 plus minus 1, that will also turn out to be 0. So yes, it is in 0 by 0 form. Correct.
Yes, sir.
Right, everyone? It is in 0 by 0 form. So can you think how we should factorize 1 minus sine of 2x? 1 minus sine of 2x. So obviously, like it is really simple. 1 can be written as sine square x plus cos square x. And then sine of 2x can be written as 2 sine x into cos x. Fine?
Yes, sir.
Everyone, do you agree to this?
Yes, sir.
Yes, sir.
Everyone? Okay. So this is basically sine x plus cos x whole square, right? Sine x minus cos x whole square. Right? A square plus b square minus 2ab. So sine x minus cos x whole square. What about the denominator? 1 plus cos of 4x. 1 plus cos of 4x. How do you write it? Do you know 1 plus cos of 2 theta? What is the formula? 1 plus cos of 2 theta. What is it? 1 plus cos of 2 theta.
Cos 2 theta.
No one knows. Cos 2 theta. Shabash. 1 plus cos 2 theta is equal to cos 2 theta.
Cos of
How much?
2 cos square theta.
by 2.
Cos of, correct, 2 cos square theta. No, it is 2 cos square theta. Correct, correct. This thing is correct. So can you just apply this thing over here? So 1 plus cos of 4x is equal to 2 cos square 2x, right? 2 cos square 2x. Agree, everyone?
Yes, sir.
अरे यार, in place of x you can just put, okay, so is the x confusing you? Like, so in place of x you just need to put 2x, you can get your answer easily. Okay, great. So now we have 2 cos square 2x. How should we do this? So it can be written as 2 cos of 2x whole squared. What is the formula for cos of 2x? What is it? Cos of 2x. So it is 2 cos square x minus sine square x whole square, right? Everyone knows this, right? Trigonometry, class 11th, completed 2 or 3
Yes.
weeks before, I guess. Okay. So now you have cos square minus sine square. How do you write a square minus b square? How do you write it? A square minus b square.
A
plus
plus
B
B
minus
into A
Ah,
minus B.
a plus b into a minus b. So 2 into, how do we write it? We should write it as cos x minus sine x whole square into cos x plus sine x whole square. Right? There is a square, so we would need to do square also. Okay. So I have got limit x tending to pi by 4. What is it now? The numerator has changed to this thing. So sine x minus cos x whole square whole divided by 2 times cos x minus sine x whole square into cos x plus sine x whole square. Can we cancel out this thing? Sine x minus cos x whole square and cos x minus sine x whole square. Can we cancel
No.
this out? No. Why?
Signs are
बोलो बोलो.
same, sir.
हाँ,
Signs.
signs are different, but square भी तो है. अरे यार, there is a square ना. See, if I'm taking x square or I'm taking minus of x square, are they both the same quantities?
Yes.
sir.
Right? So the same thing is happening over here. It is sin x minus cos x whole square, and this one is cos x minus sin x whole square. So obviously they can be cancelled.
No.
So we are left with limit extending to pi by 4, 1 by 2 cos x plus sin x whole square. Can you just evaluate this thing fast? Can you evaluate it?
4
Cos
sin
x
x
plus sin
cos x,
x whole
sir.
square.
1 by
Arey,
4 sin.
why would you
No,
need
sir.
to do that? Why would you do that? You can just
1 by
input
4.
the value directly, na? Arey, yeah. So
1
it is
by
1
4.
by 2 into what is cos of pi by 4?
44.
Cos of pi by 4. No,
1 by root 2.
cos of pi by 4 is, yes, cos of
1
pi
by
by
root
4
2.
plus sine of pi by 4. Yes,
1
correct.
by root 2.
Correct. So 1 by 2 into this thing is root 2 whole square. So 1 by 4 is my final answer. Fine?
Yes, sir.
Fine? Okay, great. So just one more question about factorizing, then we'll be moving ahead. So we have limit x tends to 2 or limit x tends to 0 under root 2 plus x minus root 2 divided by x. So is this in the 0 by 0 form, everyone? Is this in 0 by 0 form, first of all? Let us discuss that
Yes,
first.
sir.
Yes, because if you input x is equal to 0, you will get root 2 minus root 2 divided by 0. So this is in 0 by 0 form, right? This is in 0 by 0 form.
Sir.
Can you think how we could factorize this thing? How we could factorize root 2 plus x minus root 2 divided by x? How can we do this?
By rationalizing.
Rationalization,
Yes,
sir.
correct. So you have a minus 1 a plus b around, and the same a plus b would come in the denominator. Fine. So when you open this thing, so how do you open this thing? Is a plus b and a minus b. How do you open this? What
A
is
square
it
minus
equal
B
to?
A square minus B square.
Yes. So it is square root of 2 plus x whole square minus square root of 2 whole square whole,
Yes, sir.
whole by x into root 2 plus x minus root. So what is the numerator now? What is the numerator?
X,
This
sir.
thing, my first term will be 2 plus x. Yes, correct. It will be x. 2 plus x minus 2. So it will be equal to x divided by x into square root of 2 plus x minus 2. Fine. X and x got cancelled. So I am just left with limit x tends to 0, 1 by under root 2 plus x. Wait a second. It was plus, right? Okay, it was plus.
Yes, sir.
Okay. So what is this thing equal to? 1 by root 2 plus root 2.
1 by 2 root 2.
1 by 2 root. Correct. Everyone got it, everyone?
Yes, sir.
See, we are just rationalizing and cutting out the terms that are both in the numerator and denominator. That is what we are doing. Nothing else. We are not doing something new over here. It's just the same thing. Fine. So, okay. So just this similar question. Limit x tending to a. A is any constant value. So under root a plus 2x minus under root 3x whole divided by under root 3a plus x minus 2 square root x. How would we do this? Can anyone tell me?
Rationalization.
How should we rationalization? How to rationalize this thing?
Numerator and both. Numerator and
Multiply and divide, sir.
Okay. So multiply and divide by what? What should I be multiplying and dividing with?
Denominator.
Okay. Okay. So it is square root 3a plus x plus 2 root x. So the same thing in the numerator, right? This whole thing over here, correct?
Yes, sir. Yes, sir.
This is what you're trying to say, right? Okay. Let us just look at it. So for the timing, I'm just calling this whole thing as Z1. Okay. So this thing is Z1 remains at the top. Okay. So in the numerator, what will happen? It is square root a plus 2x minus square root 3x into Z1. What will happen in the denominator? What will happen in the denominator?
A square minus b square.
Is b square. What is a square? What is a square?
Root 3a plus x square.
Hmm. So what is the value? What is square root 3a plus x whole square?
3a plus x.
And what about this thing?
4x.
4x.
So now it has basically changed to square root of a plus 2x minus square root 3x into this whole quantity z1 whole divided by what is this? It's 3a minus 3x, right?
3.
3a minus 3x, right?
Yes, sir.
So has anything helped me?
No,
Yeah,
sir.
it still remains
No,
Zero.
sir.
0 by 0. It still remains in the 0 by 0 form. But one thing I can see for sure that denominator the denominator now can be written as 3 times of a minus x. Right, everyone?
Yes,
Can I say
sir.
this?
Yes, sir.
Can you relate this thing? Can you relate this thing with the immediately previous question? Are both of these somehow related? See, I agree that you say that the thing we are currently talking about, it's still in the 0 by 0 form. If it is still in the 0 by 0 form, is something possible?
Rationalization, sir, again.
Is something
Numerator.
Numerator
again rationalization? Okay.
twice the rest.
Okay. Great.
Numerator.
So, okay, great. Yes, correct. So we should be writing this as a plus 2x plus root 3x whole divided by the same thing, right? This is what you mean. This is what you
Yes.
wanted to say, right? Okay. So I'll just call this second thing as Z2 for the time being to ease my calculation. So this whole thing now has become Z1 by 3Z2 a minus x. Can you just help me with the numerator? What will this thing become? A minus b and a plus b. What will it become? Can you help me multiply these two stuff? Under root
A plus
a plus
2x
2x minus,
minus
A
3x.
correct. So is there something cancelling out?
A minus x.
A minus x. A minus x.
Correct. So I have got z1 by 3 times of z2. Now I'll just write these values again. So my z1 was square root of 3a plus x plus 2 square root of x divided by 3 times of this thing. It is square root of a plus 2x plus square root of 3x. And now
Sir, it
my
is
limit
minus, sir.
x. What is minus?
First numerator.
First numerator. Okay, where?
Now you can write under root 3a plus x minus 2 root 3. Root x.
Where are you talking about? See, I had
No,
assumed
sir,
that
no,
my
sir, I get it.
Z1.
Sorry.
See, I have assumed that my Z1 is this thing plus with a plus sign. And same thing I had assumed that my Z2 is also with a plus sign. Okay. So yes, and now I just have to substitute my limit x is tending to a. Can we do this? Is it allowed now?
Yes.
Can this thing be done now? Okay, because now it is not in 0 by 0 form. Now I
Yes,
can
sir.
approach by direct substitution. Fine. I can do it by direct
4a
substitution now.
under root
4
4a
Under root 4a plus
plus 2 under
2
root
under root
a
a divided by 3 times of hmm,
root 3a
3a, sir.
tell
Root 3a
plus root 3.
plus
3a
root
3a.
Correct. So okay. So a will get cancelled from everything. So it will be equal to 2 plus 2, that is 4 by 3 into 2 root 3. Okay. So this thing will be equal to how much? 2 by 3 root 3, right? 2 by 3 root. Fine. I know it was a bit tedious. Got it, everyone? We just needed to do the same thing twice. What we were doing earlier one time, we needed to do the same thing twice. That is why it got difficult. Okay. So yes, the method remained same. Method that we were using remains same. That we need to rationalize. So in rationalization, if see in the above question, it was just a little bit easy because we just needed to do this thing one time. A plus B, A plus B. But now we needed to do it two times. Okay. So now let us just approach with little bit of trigonometric. So I have got limit x tends to 0 sine x by x. So can you think sine x by x, which form is this coming to? Which form is this?
Sir, 1, sir.
0.
Answer.
1. Nay,
0
how much
by
is this equal to?
Sir,
0.
0.
Again 0 by 0, right?
Yes, sir.
Okay,
Yes,
correct.
sir.
So how should we approach this? Like my point is, how should we approach this? 1, like how did you get 1?
It's a formula, sir.
We have a formula,
Which
but
formula?
could be extends to 8
Rationalizing we
or equal
can.
to 0.
Which formula do you have? Like in physics?
No, sir, we don't have any
No,
formula.
sir, in maths in mathematics only. But
Huh?
extends to a. If extends to a, it's 1, sir.
Hmm. If x is tending to, can you just tell me the formula again? If x is tending to a,
Sin
so
x
sin
by
x
x
by
is
x.
By
equal to 1,
equal to
sir.
1.
No, this is not equal to 1.
extending
No.
0, sir.
No.
Extends
Okay,
to
you
0.
have this formula. Where did you see
Direct
this? In
formula, sir.
which
In
chapter?
Direct
limits and
formula, sir.
continuity only,
Limits and
sir.
continuity.
Continuity, sir.
Acha, अरे यार in college. Okay, got it.
Yes, sir.
Great. In college, right?
Yes, sir.
We
That
have
is what
direct
you were
formula, sir.
telling. अरे यार तो specify तो करो. That is what I'm thinking. When did I teach this? I got confused because I thought you are telling that I have taught this. Okay, great. If you have learned this in college, great. So how should we approach this thing? Like I have limit x tends to 0 sine x by x. It is coming out in 0 by 0 form.
We
So
should
how should I
derive,
approach this? We should.
derive that.
Multiply and
अरे
divided by
भाई.
the x, sir.
Like that
Derive,
is what I'm asking. How should we?
derivation,
Okay.
sir.
Differentiation, you mean?
Yes, sir.
Okay. Actually, okay. So you are talking about log. L'Hopital rule, right? Okay. I don't know what how that would work. But see, we actually did not need to do all of this. It was really simple. If you just remember the previous chapter, in that I had taught you that there is an infinite polynomial expansion of sin x. Does anyone remember it? What is the infinite expansion of sin x? I can write sin x as an infinite polynomial. So its value is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on up to infinite. Remember this, everyone? We had discussed this in the last chapter, sequence and series. I don't know who was present in the class. I guess Vignesh was present, right? Gayatri, Shravani, Preeti. Do you remember this thing?
No,
I
sir.
can write sin x. You don't remember this? Last class, sequence and series. Just
I
two
remember.
classes before. See, yesterday.
Yes.
Yeah, okay, I will just tell you. See, yesterday I started with limits. Okay. And just the previous class of that, we had ended sequence and series.
I didn't.
So the last class of sequence and series. Acha, you did not attend. Okay. So the ones who were present, sin x can be written as an infinite series x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial and so on. So just applying this thing over here, I have limit x tends to 0, sin x minus x cubed by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial and so on, whole divided by x. So when I divide this thing, so my x from numerator and denominator can get cancelled out. So it is 1 minus x square by 3 factorial plus x raised to 4 by 5 factorial minus x raised to 6 by 7 factorial and so on up to infinite terms. Now, is this a polynomial? If this is a polynomial, do you know how to evaluate the limit? Yes, you can just substitute x is equal to 0 in this polynomial. So what will happen if you substitute x is equal to 0?
Zero,
What
sir.
will happen?
1 minus
Your
0.
all higher order terms. Ah, yes, correct. 1
Only
minus,
one will be
it is 1 minus 0 plus 0 minus 0 and so on.
1
So it is 1. So that is why I get this limit x tends to 0, sin x by x is equal to 1. Okay. Can we approach this same thing? What should I take? Okay, let us say take tan x by x. Does anyone of you remember tan x by x expansion? Tan x expansion, sorry. Expansion of tan x? No one. Tan x, tan x. अरे यार. X plus x cubed by 3 plus 2 by 15 x raised to 5 and so on. Higher order terms. Fine? Fine, everyone? At least speak
Yes,
something.
sir.
Yes, sir.
I am telling you the series now. Fine.
Yes, sir.
Okay, so can we do this? So tan x by x. So it is x plus x cubed by 3 factor by 3 plus 2 by 15 x raised to 5 and so on. Whole divided by x. What will happen? X and x will get cancelled out
1 minus.
from both numerator and denominator. So 1 plus, it is 1 plus x square by 3 x plus 2 by 15 x raised to 4 and so on, higher order terms. And now if I'm trying to see x tending to 0, can I do it directly? Can I just substitute x is equal to 0 now?
Yes,
Yes.
sir. 1
Yeah,
minus.
because now it is a polynomial. It is a polynomial now. So I can just easily substitute. Okay, yes. So I will get the answer 1. So I have, from this I've got one more identity, limit x tending to 0, tan x by x is also 1. I don't know why, like, I don't know who of those were there. In last class of sequence and series was on this only, infinite series. So just come revised, okay?
Okay, sir.
We revised with all of this. Okay. Now let us do, okay. So let us solve some basic questions related to this. First question, really simple. Limit x tending to 0, 1 minus cos of 2x whole divided by x square. Okay. Or, okay, so first let us do even more easier question. Limit x tending to 0, 3 sine square x by x square. How would you do this? The right side question first. Limit x tending to 0, 3 sine square x by x square. How should we do it? Anyone? So, like, you just need to do nothing. Limit x tends to 0, 3 into
3 is
sine x by x whole square, right? Yes, sine x by x whole square. So now what will be your next step in this? I already know the limit of sine x by x,
1.
Sir.
right?
Yes,
I
sir.
already know the limit.
Answer
So I
is
can, if I know the limit, 3, correct.
yes, sir.
Answer is 3. I can just directly substitute the value because I know it. I know what is sine x by x when x is tending to 0. It is 1. So 3 into 1 square, my answer will be 3. Really simple. Now let us discuss this one. So 1 minus cos of 2x by x square. What is 1 minus cos of 2x?
Cos square 2. Cos square x.
अरे यार भाई,
Square
गलत आंसर यार, विघ्नेश भाई.
2 cos square theta, sir.
How
Sorry,
much
sorry.
is it?
2 cos
2
square
cos
theta.
square theta, wrong.
theta.
It is 2 sine square theta. Hey bhai, it is 2 sine square theta. No one knows. Yeah, how is that possible? You have studied, not trigonometry, Pakka.
Yes, sir, yes, sir.
What you are saying, that is 1 plus cos of 2x. That is equal to this thing.
Yes, sir.
1 minus cos is 2 of sine square यार. पता नहीं क्या करते हो भाई. So limit extending to 0, 2 sine square x by x square. Can we do this? Can we
Yes,
do
yes.
this? So tell me. Tell if
Two,
we
sir,
can
answer.
do, so just tell me. How much? 2, correct. Because it is 2 into sine x by x whole square, right?
Yes, sir.
So sine x by x I already know. I can just
1.
take it. So yes, so 2 into 1 square, answer is 2, correct. Yeah, I don't know what you are doing, but doesn't seem really good. See, like, no one, just 2 classes before I have discussed infinite expansion of sine x and tan x. Like yesterday we had started with limits, and just the class before we had completed this, the sine x and tan x expansions. Okay, fine. So now we have limit x tending to 0, sine 3x by x. How can we do this? Sine 3x by x. Can you think? Anyone?
So can we use formula?
Which formula? Sine
Divide,
of 3x.
multiplying and
You will
dividing with
use formula
3,
for
sir.
sine of 3x.
Numerator
Okay.
and
Yes, that also you can do. Yes. So actually that is the correct method. So it is limit x tending to. So yeah, I guess using sine of 3x will make it longer. But okay, it should work in that way also. Can you tell me formula for sine of 3x? What is it?
So
Sine of 3x.
3 sin A,
बोलो.
3 sin A minus
बोलो.
4 sin cube A.
Okay, चलो उसके तरीके से कर लो. Again, can you tell me?
3
3
sin
sin
A
x plus 4 sin
minus
cube x. अच्छा,
माइनस आता
minus.
होगा.
Okay.
Yes, sir.
Okay. Okay. This thing? That's what you're saying? Okay. So limit x tends to 0, sine of 3x by x. Okay. So this thing I'm just substituting over here. So it is 3 sine x minus 4 sine cube x. Fine? Fine?
Yes, sir.
Yes,
Okay.
sir.
So I can just like use distributive property. So 3 sine x by x minus limit x tends to 0, 4 sine cube x by x. So the first part you can really easily calculate. What is 3 sine x by x?
Sir, 3. 3 minus
Yes, 3. First part is 3. What about the second part? It is 4 sine cube x by x. So this thing can be written as 4 sine x by x into sine square x.
20.
Right?
Yes, sir.
Right, everyone?
Yes, sir.
So what is sine by x? What is the value of sine x by x?
1, sir.
Sine 4 into 1. And what is the value of sine square x? What will it be? When x is close to 0, what is the value of sine square x?
0.
Correct, 0. So this thing,
0, sir, answer.
3 minus 0. So final answer
3.
is 3. Right? Okay, great. But instead of doing that, I'll just show you one small trick. So I have limit extending to 0. Fine. So what will happen if you multiply and divide by 3? So I have sine of 3x by 3x into 3. Can I write it like this, everyone?
Yes, sir.
Everyone? Okay.
Yes,
So
sir, you
now
can.
I'll just, in order to deploy this trick, just think that I have a variable named as y whose value is equal to 3x. Fine. So if my x is tending to 0, where is my y tending to? If my x is really close to 0, where is my y?
3.
0, right? 3x. That will also be close to 0. So I have limit of x tending to 0. Okay. I have sine of 3x. So sine of y by y into 3. And now instead of writing x tending to 0, I can write y tending to 0. Okay. That is how we change the variable. So we have changed our variable from x to y. So now can you help me evaluate this in y? Limit y tends to 0, sine y by y multiplied by 3. What will it be equal to? What will this thing be equal to?
3,
I
sir.
just change my variable from,
Is it
yes, it is 1 into 3, 3, right? Really simple. It has got nothing to do. Because what will happen, sine y by y, when y is tending to 0, it will be changing my variable from x to y. Fine. Okay, so this change of variable is little bit confusing. So let us solve a few more questions. So I have
But in
limit.
previous question, we have answer 0. We got 0. No, sir.
In which question?
Before solving trick question.
Which question? 3 of the first part minus 0. So it is 3.
Okay, sir. Sorry.
Hmm. Okay. So I have sine AX by sine BX. So see, I have sine of AX by sine of BX. So
Just
I can
multiply
write this thing like,
and divide by x.
yes, yes, correct. So I can write sine X by AX whole by sine BX by BX. And now I should be writing, since I need to do this thing, so I can write it as AX by BX because I would need to cancel out this term. What is AX by BX first of all? AX by BX, what is it? AX
0
divided by BX. A by B. Arey yaar.
One,
It
sir.
is A by B. Na? Like I was 1. A and B are any constants, okay?
Yes, sir.
It is A by B. Why will it be 1? Okay. So this thing, my overall turned into A by B, sine of AX by AX divided by sine of BX by BX. Right, everyone?
1
Agrees?
into a by b.
Everyone agrees to this, right? Now,
Yes,
I would need two variables for
By X,
two variables to solve this. Okay. So I am assuming my y is equal to ax and my z is equal to bx. So if my x is tending to 0, where is my y going to?
Y is also tending to 0, sir.
0 y tends to 0.
What about z? What about z?
Z
Tending to
also 0.
What about z? Okay.
tending
So
to
I'll
0.
just write this thing as a by b limit y tending to 0 sine y by y. Okay. Divided by limit z
Sin
tending
z
to
by
0
z.
sine z by z. So see how we using the two variables we have done this thing very easily. Now can you tell me this value directly?
A by b,
So it
sir.
is a.
Sir, A by B.
What will be the denominator? Yes. So 1 by 1. This thing is equal to a by b. A by
Yes,
b
sir.
is my formula. Got it, everyone?
Yes, sir.
Yes, sir.
Okay. So just
Sir, once to say that third step, sir.
more properties related to it. So limit uh, x tending to a. Okay, a is any constant. I have sine of x minus a divided by x minus a. The same thing. Limit x tending to a tan of x minus a divided by x minus a. So one thing you can think, you may think is that we can maybe use sine of a minus b. Same thing you can use here if you wish to, tan of a minus b, but it will go really long and you will not understand the concept. The concept we are talking about here is change of values, the change of variable. So can you think how we can change the variable? It is definitely in 0 by 0 form. So what will happen if I assume my y is equal to x minus a? So if my x is tending to a, where will my y tend to?
0, sir.
Okay, yes, because a minus a, so it will tend to 0. So I have limit y tending to 0, sine of y by y, right?
Yes, sir.
Right?
Yes, sir.
So what is this value equal to? What is this value equal to?
1.
1.
1. Okay,
1,
the same
sir.
about this thing. Same thing
Sir.
here. So y I will make it as x minus a. Fine. I will make my y as x minus a. So where will my y tend to now? Again 0. So
0,
this thing
sir.
is limit y tends to 0 tan y by y. What is this equal to? 1.
1.
Is this equal to 1?
Yes, sir.
Okay,
Yes,
great.
sir. It's 1.
So we have got, have you learned about uh what was that thing called? Inverse trigonometric functions in college maybe or with Kevin sir? Inverse trigonometry? Not learned?
No, sir.
Okay, not an issue. Okay, so let us do just one or two more questions. Or okay, just a minute. Or before doing this, fine. Can you think anything? First, we will be doing the right hand side. We will be solving the right hand side question first. So, can you think how we should approach this sine of log x by log x? What should I do? What should I take my variable, my new variable as? What will be my new variable? Just think easily, like it's not very difficult. What is inside sine? What is inside sine?
Log x.
Log it.
So I anyways need sine by y or sine of something divided by that thing. So why can't I take my y as log x? So if my x is close to 1, where is my y close to? Log of x.
Zero,
Everyone
sir.
remembers log 0.
Log is 0, sir.
Ah, yes. Log of 1 is 0. So limit y tending to 0, sine of y by y. So what is the
1.
value? Final value?
1.
1, sir.
1. Correct. Okay. So just one more homework. So these two will be your homework questions. This one and one more. So this one won't require variable change. Okay. The first question won't require variable change. This one. Limit x tends to pi by 2. This one. So the second one I'm giving limit x tending to 2. X square minus x minus 2 by x square minus 2x minus sine of x minus 2. Fine. Everyone. Okay. So these two are your homework questions. That's it for today. Thank you.
Okay, sir.
Ma'am, please end the class.
Thank you, sir.
Thank you.
Students,
Please come revised with everything, okay? See, I just taught that thing 2 classes before, but still, like most of you were present that day. Vignesh was present, I remember. I'm not sure who else was present, but many people were present that day. Bhavna was also present, I guess. So, but still, like just 2 classes after, if I'm trying to recall the same thing, you don't know. So it's really disappointing, okay? Just come revised with everything.
Thank you, sir.
all right, students, join the next session.